And our last session for section 3.1. What a big section. Here we'll again look at graphing, but with a different method than we did before. And we'll also talk about finding domain and range for a linear equation. Okay, so graphing with a table. Last time we learned how to graph by finding the x and y intercepts and then graphing those two and connecting the dots. This time we're going to do something called graphing with a table. So to graph with a table, you'll need to first put the equation in slope-intercept form. Now, we'll talk about this a lot more in a later section. Honestly, right now I could just say, first, get y by itself. This isn't mathematically required you do this, but I promise it will make doing this much easier if you do that. So don't worry about this term. I might use it, but the point is you need to get the y by itself. So right now the y is being crowded by 2x, so that's in standard form, but that's not what we want right now. So we'll subtract the 2x over to this side. So we get y equals 3 minus 2x. Second, make a table that looks like this below. Okay, so in the middle here, we're going to put whatever y is equal to. Y is equal to 3 minus 2x. And different books, different teachers would have different rules on how many points we need to get from a table. I'm just going to choose 3. And here's the cool part. You get to pick them. So you get to pick what 3 values, what 3 numbers you want to plug in for x. Now I recommend just use 0, 1, and 2. Because they're small and they're easy, they should be easy to get on a graph they give you. But if you want to pick 1, 2, 3, or -1, 0, 1, that's cool. Now technically you could pick things like 100, 101, 102, but that's not on the graph, so we're not going to go that far. So this middle area is just for you to do the work in, because we've said we're going to choose an ordered pair where x is 0. So I'm going to plug in 0 for x. 2 times 0 is 0. 3 minus 0 is 3. So this is an ordered pair, 0, 3. So I could go ahead and plot that on this graph. Now I'm choosing to plug in 1 for x. 2 times 1 is 2. 3 minus 2 is 1. So this is the ordered pair 1, 1. 1, 1. Now I'll plug in 2 for x. 2 times 2 is 4. 3 minus 4 is -1. So this is the ordered pair 2, -1. So I go to 2, I go down to -1. And you can see that makes a straight line. So we can draw a line through those 3 points, and we have graphed the line. So we already did part 3, graph the ordered pairs that you found and draw a line through the points. Now, just so you know, back when I was taught Algebra 1, we just did the table like this. We just wrote 0, 1, 2. Then we did all this work somewhere else and wrote it right here. If you want to do just this and do the work in your head or do the work off somewhere else, that's fine. You could just work it out and get the y values. This is what our book does, and I understand and think it is helpful to do the work to make sure you're doing it correctly to get the y. But it's up to you whether you include this in your table or not. Okay, one more example of that, just right here. So graph y equals 1/3 x plus 2 by making a table. So the good news is this one already has y by itself, so I don't have to rewrite anything. Now the tricky part here is this fraction. You can just plug in 0, 1, and 2 like we did last time. Nothing wrong with doing that. But if you do 0, 1, and 2, you're going to get some fractions and some decimals as your y values. That's not wrong, but that's obviously going to be a little harder to graph accurately than if we just have whole numbers. So what I recommend when they have a fraction is count by whatever number the denominator is. So in other words, instead of doing 0, 1, 2, I'm going to do 0, 3, 6. Because this will help prevent me from having decimals or fractions in my answers. So if that had been 1/2, I would have done 0, 2, 4. If that had been 1/4, I would have done 0, 4, 8. Or 8 would be off the graph, so I could do -4, 0, 4 as well. So let's plug these in and see what we get. So 1/3 times 0 is 0. 0 plus 2 is 2. So I have the ordered pair 0, 2. 1/3 times 3 is 1. So 3 times 1/3 is 1. The 3's basically cancel out, leaving just the 1. 1 plus 2 is 3. So we have the ordered pair 3, 3. So 3, 3. Then if I plug in 6, 1/3 times 6 is 2. 2 plus 2 is 4. So I have the ordered pair 6, 4. So go all the way out to the edge. 6, 1, 2, 3, 4. And that's our line. So that's how we graph by using a table. We want to make sure y is by itself. Pick some x values to plug in for x. That gives us 3 ordered pairs that we can then graph and draw a line through. Okay, we also need to talk about horizontal and vertical lines. Now, all the lines we've dealt with up to this point, at least with graphs, have been diagonal. They've been slanted. They're straight lines. I just mean, they're slanted up like this, or they could be slanted down like this. But horizontal lines, that's ones that are flat, like this. They're always written in the form y equals c. So y equals 3 is a horizontal line. Y equals -1 is a horizontal line. Y equals 4.1 is horizontal. Y equals 0 is horizontal. Y equals -12 is horizontal. And it turns out horizontal lines have a slope of 0. So anytime it's a flat line, horizontal, it has a slope of 0. And let's go ahead and let me show you how to graph these. So what this is saying, as soon as you see y equals a number, you know it's a horizontal line. It says y equals 2. So remember how we found intercepts. That means the intercept is at 2. So we know it goes through this point. And we know it's horizontal, so we just draw a horizontal line that goes through that point. On this one, they tell us that y is -3. So that would mean it hits the y-axis at -3. So we draw a horizontal line through it at -3. And what is their slope? Their slope is 0. Horizontal lines have a slope of 0. So this is more a memory thing. This is something you just need to stick in your brain. Horizontal happens when y equals a number. In other words, there's no x that shows up in the equation. It's a horizontal line, and the slope is 0. Now vertical lines are basically the opposite. Vertical lines are the ones that are straight up and down. And instead of having y equals a number, they are x equals a number. So I just use all the same numbers up here, but put x equals. And the slope of vertical lines is undefined. Because basically, that's just going infinitely up. So we just say the slope is undefined. Now, when you do the slope, well, never mind, I get ahead of myself. We're not there yet. So the slope is undefined when you have a vertical line. So let's graph them. As soon as you see x equals a number, you should know, that's going to be a vertical line. And it tells me x is -4, so that means on the x-axis I can mark a point at -4. Then I can draw a vertical line through that point. This one says x equals +4. So I look at the x-axis, mark +4, and I draw a line through that point. And their slope is undefined. So again, this is mostly a memory thing. You're just going to have to choose to make the effort to remember horizontal lines. That's when y is equal to a number and there's no x at all. Their slope is 0. Vertical lines are when x equals a number and their slope is undefined. And you should be able to take any one of those and conclude the other two. In other words, if they tell you this, the slope is undefined, you know, oh, that's a vertical line. If they tell you the slope is 0, you should know, oh, that's a horizontal line. So you can go from one to the other. Well, by that I mean those three up there, or these three down here. They're all interchangeable with each other as groups. Last thing, domain and range for linear functions. Just a reminder, domain is all the possible x values that exist in an equation or a function. The range is all possible y values that exist in a linear function. And there's just three possibilities when we have straight lines. If we have a horizontal line, just a reminder, it's going to look like this. So it's horizontal. So another way you can think about it with a graph, domain tells you how far left and right you can go, because the x-axis is horizontal. So domain for a horizontal line is negative infinity, because it goes forever to the left, and positive infinity, because it goes forever to the right. I know this looks like an ordered pair, but it's actually not. It's an interval. It's written the same way. Don't ask me why. I'm not the math judge here. It's just what they decided. So it's saying it goes all the way down to negative infinity and all the way up to positive infinity. So it goes forever down and forever up, forever left, forever right. But the range, that's how high and low it goes, is just whatever this number is. Because think about a horizontal line, it never goes up, never goes down. It just stays at one number all the time. So whatever number it's equal to, that's your range. And vertical is just kind of the opposite. Vertical, remember it's of this form, x equals c. Its domain is that number because it never goes left or right. It just stays at one x value all the time. So whatever this number is, that's your domain. It's not an interval because it's just a single number. The range is negative infinity because it goes down forever, up to positive infinity because it goes up forever. Now all other lines, doesn't matter if they're in standard form or not. The point is, if it only has a y, this is true. If it only has an x, this is true. If they have both an x and a y, then it turns out the domain is negative infinity to positive infinity, and the range is negative infinity to positive infinity. So I'm just making one up, but let's say I had this. Now this goes up and left forever. So it goes left forever, making the domain negative infinity, and goes right forever, making that positive infinity. It goes down forever, making that negative infinity, goes up forever, making that positive infinity. So if you have both an x and a y, the domain and range are negative infinity to positive infinity. So let's practice that right here. So this is a horizontal line. This is the line right here. Sorry, oh, wow. Try that again. There's the line right there. So domain says how far left and right does it go. It goes forever to the left and forever to the right. So its domain's negative infinity to positive infinity. Its range is negative 2. Now that's a really weird bracket. If you don't have to put the bracket, I don't think we have to worry about that at this level of math. If you just put negative 2 as your answer, I'm cool with that. Okay, for this vertical line right here, the domain, remember that's how far left and right it goes. Well, it only is at one spot. That's at 4. So the domain is 4. The range is how high and low it goes. It goes up forever, it goes down forever. So it'd be negative infinity to positive infinity. This last one, it has both an x and a y. When it has both, the domain is negative infinity to positive infinity, and so is the range. So this also is just mostly a memory thing. You got to remember, if it's horizontal, If there's only a y, domain's infinite, the range is one number. If there's no y, there's only an x, the domain is one number, the range is infinite. If it has both, then both the domain and the range are infinite.